Well, for 49, I'll show you what I've done. I've not got the right answer yet, I'll tell you though. We've got our ladder here, and we know it's got a weight of M. We don't know how far up though, so I'm going to call that how far up. I'll just call that A for something there. And we know this weight here is mg. We've also told, well, clearly there's a normal reaction here, and there's some friction going in there. You're told that the coefficient of friction at the ground is 0.3. So I'm just going to put 0.3 R on it there. The wall has got a normal reaction here. You know, I call mine S. And there's some friction on the wall as well. They've said that the coefficient of friction there is 0.7. So I'm going to call that one 0.7S. And I'm going to do forces up and down first of all. So let's do forces to the right. So the forces to the right are the 0.3 R, and the forces to the left are the S. So 0.3 R minus S equals 0. So that tells me S is actually equal to 0.3 R. And that might be better to actually change this now to a 0.3 R. And maybe this one up here, we could change that. 0.7 times 0.3 R is 0.21 R. So now let's go up. The forces going up are the R we've got here plus this one here that we've just figured out, 0.21 R, minus the mg, and that will equal 0. And so that tells me here that I've got 1.21 R equals mg. I can actually find out what R is. R is mg over 1.21. I'm going to use that in a minute to put into those ones there. Should we work those out? Let's just tell you now that 0.3 R is 0.3 times by that. And that's going to give, I'm just going to do it as a fraction, 30 over 121 mg. And the other one, let's work out that one there, the 0.21 R, well, that one's going to be 21 over 121 mg. Just working those out before I do the moments. So we're going to do moments about the ground here, moments about that point there. First one is the weight here. So we've got force is mg, the distance there to there is a, and the little bit of trig that we want, because we don't want that diagonal distance, we want that perpendicular distance there. So that is cos 60. Then what's going the other way is this force here. And so that force is this one here, isn't it? 30 over 121 mg. The distance there to there, well, I'm just calling that 1 for the length of the ladder. And the bit of trig we want, because we really want that distance there, it's the distance there, so that's the sine of 60. We also want to take away this force here. This one's turning it that way as well, isn't it? So that one there is the 21 over 121 mg. The distance there to there again is 1, but we really want this distance here, so that's another cos 60. And that will equal 0. Well, we're going to add both of those two over there. So let's put the equals there and make that a plus. And then we can see that everything's got an mg in it. So divide everything by mg. And we want to know what A is. So I'm going to divide everything by cos 60. So if I divide this one by cos 60, well, they'll just cancel out. And if I divide this one by cos 60, I'm actually getting a tan 60 there, aren't I? And when I tap that into the calculator, I get A is 0.603. I say that's not the answer it's given in the back of the book, so we'll need to have a discussion on how to get that.